In mechanistic maps, we've examined the claim that the machine view of the world is the only possible scientific worldview. And we have concluded that this claim is false. Just like any other human worldview, it is based on metaphysical assumptions which are neither scientifically justified nor supported by any evidence. What we do now is look how much of this baggage is still hampering us today. Physics has come a long way in the 300 years since Newton's death, and we no longer believe that the world is a clockwork. Instead, we claim that the world is or behaves like a computer. To understand this claim, we need to first understand what computation means. The theory of computation is not a theory of physics. Instead, it is a theory of a particular human activity to calculate by rote, to solve mathematical problems with a pen and paper. Through some twists of history, this model of a human activity was turned into a model of a universal machine, which in turn underlies all the digital technology that we use today. This technology allows us to simulate physical processes, which has led to the claim that those physical processes are, in fact, processes of computation. This idea starts with an examination of the physical requirements of computation. How do the laws of physics constrain our ability to compute? To cut a long story short, the universe, the observable universe, in any case, does put limits on what can be computed. But those limits are so unbelievably large that they will never matter to us in practice. On the flip side of the coin, we look at whether the modern laws of physics, quantum mechanics, and the theory of relativity are computable. And we conclude that strictly speaking, they are not. But nevertheless, we can approximate them using simulations to an arbitrary degree of precision. And so again, in practice, these limitations do not really matter. But some physicists have moved from the idea that computation can be implemented in various physical processes to the idea that every single physical process in the world has to be a process of computation. We examine various of those claims and show that it is very different to claim that you can simulate physical processes using a computer, and that those physical processes are, in fact, processes of computation. The former is an empirically testable claim, but the latter, again, is an untestable and unverified metaphysical assumption that we do not really need to do science. What we will do next is examine an alternative to the machine view of the world. It has its own metaphysical assumptions, but we would argue that they restrict our ability to ask questions about the world, our acceptance of explanations, of what is scientific, that they restrict those abilities much less than the machine view of the world today. And they also give us a more human, a more humble relation with the world. This concludes the first part of the book, a criticism of the machine view of the world. What is coming next is an examination of a new kind of theory of knowledge. A theory of knowledge for limited beings in a large world.